Welcome to this video on data handling, and in this video we're going to look at how we create a probability tree diagram and use it to answer probability questions. Okay, so before we do that then, here's a starter, and for this starter question then we're going to roll two fair dice. I want us to list all the possible outcomes that can occur when we do roll two fair dice. So I've started you off with a list, so we could roll a 1 and another 1, or we could roll a 1 and a 2 on the second dice, and so on. What I want you to do now is have a go at listing the rest of those. And once you've done that, I want you then to calculate the probability that when two dice are rolled that no 6 occurs on the roll. Okay, so pause the video now and have a go. Okay, welcome back then. So hopefully you've managed to write down all your possible outcomes. So it's quite a big list in this case here. So here are all the possibilities. And if we have a look, then we've got 36 potential outcomes. Okay, so it's quite a lot of outcomes for this type of problem. Okay, and that could be quite a tough list, quite a tedious list to put together. Okay, but now we know that there are 36 different outcomes when we roll two dice. We've got an idea on what the probability is going to be out of. So when two dice are rolled, the probability there are no 6s at all, well, that would be all of these pairs here. Okay, so it's going to be everything here. Look, so if we have a look carefully at all these pairs in here, there are no 6s with either dice, and these ones out here do have at least one 6, and this last one here has two 6s. So in here there are 25 different ways that you can roll a dice and not get a 6 on either of them. So the probability of no 6 occurring is 25 out of 36. Okay, so well done if you got that question right and listed all the outcomes successfully. Okay, so let's have a look at how we deal with tree diagrams. So I'm going to show you now how we do this same sort of problem as the starter question, all right, but via the use of a probability tree diagram. So as we're going through the video, press pause to copy down the examples that will help you with your main task for the day. Okay, so again, two fair dice are rolled. Okay, so this is your first dice here. Okay, and this will be your outcome on your second dice. All right, so what's the probability that no 6 occurs? So you're either going to get a 6, yes, or no, you're not going to get a 6 with your first dice. So on a dice, there's 6 possible outcomes on any given dice: 1, 2, 3, 4, 5, or a 6. So the probability that you do get a 6 is 1 out of 6. Now we can write that in fractional form. So the probability that the first dice lands on a 6 is 1 out of 6. And there are 5 numbers that are not 6s. So the probability that you do not roll a 6 is 5 out of 6. Okay, and then on the second dice, you roll it again. Okay, and it's either going to land on a 6 or it's not going to land on a 6. Okay, so the probability now we know that it lands on a 6 is 1 out of 6. And for not landing on a 6, it's 5 out of 6. So we can quickly fill in our tree diagram. Okay, now the purpose of having all these branches on the tree diagram is so that we cover all the possible outcomes. Okay, so the outcome is if we follow this branch here, then the first dice lands on a 6, and then the second dice also lands on a 6. That means it lands on a 6 both times. Now, to work out the probability of that happening, then we need to take the two probabilities from the tree diagram, so 1, 6 and 1, 6, and we would multiply those together. So a recap on multiplying fractions: you multiply the numerators together, so 1 times 1 is 1, and 6 times 6 is 36. So the probability of getting two 6s is 1 out of 36. And if I refer back to the starter question here, that's the only one which, sorry, where 2 6s occur. So there it is there. So 2 6s, there's only one of them. So 1 out of 36. Okay. We could also, though, roll a 6 with the first dice, but not on the second dice. So the outcome would be yes, followed by no. So we would multiply this 1/6 by this 5/6 this time. So we would follow the yes, no probabilities. So we would do 1 out of 6 times 5 out of 6. And again, multiply through the numerators and denominators. So we get 5 out of 36. It could have happened the other way around. So no 6 on the first row, but a 6 on the second row. So this time we would multiply 5/6 by 1/6. So multiply through there, we get 5 out of 36. And finally, we might not get a 6 on the first row, and we might not get a 6 on the second row. So no 6s at all on either row. So we take the two probabilities on the no branches, so 5/6 and 5/6, and multiply them together. So we've got 5/6 multiplied by 5/6, and that comes to 25 over 36. Okay, now if we have a look at all these probabilities here, okay, we'll notice that 1 over 36, 5 over 36, 5 over 36, and 25 over 36. If we add them all together, the numerators all add up to 36. So that's all possibilities, 36 out of 36. Now, what's the probability that no 6s occur? Well, that's this one here, none at all. And so the probability is 25 out of 36. So the probability of getting no 6s is equal to 25 out of 36. Okay, now we already knew that from the start of the question because we already worked out that these are all the possible outcomes, okay? But this is a much, much shorter way without having to list all those outcomes of getting that probability. Okay, hope that makes sense. Okay, example 2 then. In this question then, we've got 6 red balls and 4 black balls in a bag. Richard selects a Richard selects a ball at random and replaces it. That means he puts it back into the bag. He then selects another ball. So we're being asked to draw a tree diagram to show all the possibilities and probabilities. And then we're being asked to find the probability that he picked out 2 red balls. Okay, so we've got 6 red and 4 black. So the first ball that he picks out is represented in this first tree here. And then the second ball that he picks out is represented in these trees here. So it depends on whether we pick a red or a black ball first. Okay, so the probability he picks a red ball. Well, there are 6 red balls, we know that, and there are 4 black. So altogether, there are 10 balls in the bag. So the probability he picks a red is 6 out of 10. And the probability he picks a black ball out would be 4 out of 10. We could put these into decimals if we wanted to, so 0.6 and 0.4. But for this example, I'm going to keep them as fractions. Now, when he places the ball back in the bag, he's then going to pick out a second ball. And again, it can either be red or black. So as he's replaced the ball back in the bag, there's still 10 balls in there, 6 red and 4 black. So we can complete our tree diagram. Now, this time, our outcomes for this type of probability is a red ball followed by a second red ball, or picking a red ball first followed by a black ball, or we could pick a black ball first followed by a red ball, or we could pick a black ball with another black ball, so we could pick 2 black balls. Now we can work out all the probabilities associated with this like I did on example number 1. However, if we go back to the question, I'm only being asked to find the probability of 2 red balls. So I don't need to know for this question the probability outcomes of these other 3 scenarios. So the probability of 2 red balls then, so we need to follow the 2 probabilities from the reds, so 6/10 and 6/10. So we know the probability for this is going to be 6/10 for the first red ball, multiplied by 6/10 for the second red ball. Now, 6 times 6 is 36. 10 times 10 is 100. That's the only one I need to work out for this question. So the probability I pick out 2 reds will be 36 out of 100. You may choose to simplify that down or put that into a decimal form, but usually that's not necessary with probability. Okay, example 3 then. So the probability that Jason has orange juice on any given day is 0.7. So the first day and the second day. So now we've got a decimal in here. So he's either going to have orange juice, yes, or he's not, no, on either day. Okay, the probability he has orange juice is 0.7. So I can fill that in. So how do I find the probability he won't? Well, the branches on the probability tree must add up to a whole 1. So I know that 0.3 plus 0.7 adds up to a whole 1. Okay, and then I can fill these in because on each day it's the same outcomes. And there's my probability tree now filled in. So complete the tree diagram to show the outcomes on 2 successive days. We've done it. And then if we wanted to work out any probabilities, so we could use the tree diagram. So if we want the probability that he had juice on 1 day only, okay, that means he might have it on the first day, but not on the second day, or not on the first day, but has it on the second day. So we want this yes, no, so 1 day only. So it would be 0.7 multiplied by 0.3, or in probability means to add the probabilities up, or no on the first day and yes on the second day. So 0.3 multiplied by 0.7, and then it's a case of working these out. So 0.3 multiplied by 0.7 gives me 0.21, and 0.3 times 0.7 gives me another 0.21. And if I add those two probabilities up, then altogether that gives me a probability of 0.42 that he has orange juice on 1 day only. Okay, so for your main task now, you need to open the attached probability tree diagrams file. Okay, there's 4 questions on there. All right, so have a go at them, and when you're ready, come back and have a look at the check-in question. Okay, welcome back then. So in this check-in question, the probability that a rugby team wins a match is 0.6. The probability it loses is 0.3. The team plays 2 matches. We're being asked to draw a tree diagram to show all outcomes. Hint, don't forget all possible results. All right, and then I'm be asking you to calculate the probability the team wins just 1 match. I want you to pause the video now, have a go at it yourself, and when you're ready to check your work, press play. So pause the video now. Okay, welcome back then. So the probability that we win a match is 0.6. So we can win a match, it's 0.6. So this is your first match. Okay, so the probability we lose the match is 0.3. So if I say we lose the first match, 0.3. But that only adds up to 0.9, and it's because in a game of rugby, we could also draw the match. So if I add 0.1 onto that, that gives me a whole 1. So the second match, the same probabilities apply. So we can win, lose, or draw each time. Okay, so again, the probabilities for a win is 0.6, 0.3 for a loss, and 0.1 for a draw. So we can quickly complete our tree diagram. And now we refer now to our question, which means they win just 1 match. So if they win the first match, yeah, then they can't win the second match as well. So they could win and lose, or win and draw, and that would be winning 1 match. Or they could lose the first match and win the second one. Or they could draw the first match and win the second one. So there's the different ways that we can win just 1 match. And again, now we just need to multiply the probabilities together. Okay, so we've got these together here. To lose and win would be 0.3 times 0.6. To draw and win would be 0.1 times 0.6. And we would work them out and add them all up. I'm going to do that quickly because time for the video is running short. And if we add them up there, it gives us a final answer of 0.48. So well done if you got that correct. Thank you very much for listening to this video.